This video deals with the topic of fluid mechanics and is based on the question: a reservoir is to provide water to a turbine which has an elevation of 200 meters below the surface of the reservoir. A steel pipe of 30 centimeters diameter and effective length 500 meters connects the reservoir and turbine. If the water flow rate is 300 liters per second and the turbine generator produces 435 kilowatts of useful electrical power, estimate the following: the efficiency of the turbine generator combination, the pressure at the inlet of the turbine, and the pressure dissipated by pipe friction. We are given the roughness of the pipe as 0.046 millimeters and the viscosity of water as 0.001. The data given to us in the question is shown in this diagram. We must first find the flow velocity V, which is given to us by Q, the flow rate, divided by A, the flow area. Q is given to us in the question as 300 liters per second, which we change to meters cubed per second to get 0.3. And A is given to us as pi d squared divided by 4, with d being the diameter of the pipe in meters. Therefore, we get a flow velocity of 4.244 meters per second. To find the friction factor coefficient, we must first calculate the Reynolds number, given to us as rho multiplied by the velocity multiplied by the diameter of the pipe, divided by the viscosity of water, to give us a Reynolds number of 1,273,200. We next calculate the roughness ratio as 0.046 divided by 300 to get 0.00015. We use the following graph to find the friction factor coefficient. The pink dot on this diagram allows us to estimate what the friction factor coefficient may be. A chosen value of 0.0033 for the friction factor was used in these calculations. To calculate the frictional loss, we use the formula 2F multiplied by V squared multiplied by L divided by D, with F being the friction factor coefficient, V being the flow velocity, which is previously calculated, L being the length of the reservoir given to us as 500 meters, divided by the diameter of the reservoir, to give us a frictional loss of 198.13 joules per kilogram. The energy equation that is to be applied between the reservoir surface and the outlet is the following equation, with U being the flow velocity in meters per second, G being the speed of gravity as we know as minus 9.81 meters per second, delta Z being the difference in depth between the reservoir and turbine given to us in the question as 200 meters, and F being the frictional loss calculated previously as 198.13 joules per kilogram. The other parts of this equation can be neglected. Therefore, we get W as 1754.87 joules per kilogram. We use this to calculate the power transferred to the turbine by multiplying it by 300 kilograms per second to give us power of 526.461 kilowatts. Part A of the question asked us for the efficiency of the turbine generator combination, which is calculated as the actual power output, given to us in the question as 435 kilowatts, divided by the power calculated as 526.461 kilowatts, to give us an efficiency of 82.63%. Part B of the question asks us for the pressure at the inlet of the turbine. Here we must apply the energy equation from earlier between the reservoir and the turbine inlet, using only the delta P divided by rho plus G delta Z parts of the equation. Pressure 1 is given as 0 and we are looking to calculate pressure 2. We find the pressure 2 as 19.62 bar. Part C of the question asked us for the power dissipated by the pipe friction. Loss by the friction is calculated to be 300 kilograms per second multiplied by the frictional loss, 198.13 joules per kilogram, to give us power dissipated by the pipe friction of 59.439 kilowatts. Thank you for watching.